Okay, and last lecturer on this session, Dr. Tzipi Horowitz-Kraus from the Technion, Neuroplasticity in Developmental Disorders, the specific case of dyslexia.
Thank you so much. Thank you, Dedi, for this wonderful talk. I don't see you, but we keep talking about, going back to the question that was asked before, we keep talking about, what's the effect? How can you measure an effect? One of the most wonderful ways of measuring an effect and to see whether it's mechanistic or just a change in pathways is actually using neuroimaging, and this is what I'm going to talk about today. First of all, I'm really, really happy to be here. Thank you, Dana, for inviting me. This is also coming back home for me. I studied my biology and neurobiochemistry studies here, and went to PhD postdoc, and came back to Israel to actually open the first neuroimaging pediatric lab in the country that actually scans healthy, typically developing children. Today I'm going to talk about the neuroplasticity. I think that all of us in the audience believe in neuroplasticity in children, otherwise we wouldn't be here. But specifically, I will talk about dyslexia, which is the main area of my interest, but then I'm going to elaborate to other neurodevelopmental and neurological diseases. So these are my disclosures, and I'm going to start with introducing dyslexia and specifically executive functions. I will talk a little bit about performing functional MRI in children. Very challenging, but very, very rewarding. And I will present some of our results looking at the effect of intervention on neural circuits related to executive functions and reading in children with dyslexia, both by means of functional MRI ball design and resting state. And I will try to keep the time short. So what actually is reading? We talk about dyslexia. Dyslexia is a reading difficulty, and I will talk some more about it specifically. But what is it reading? Reading is a new human invention. Basically, it's 5,000 years old-ish, whereas the Egyptians, who were one of the first ones who developed the writing system, basically took picture and named it in the verbal matching name for it. So whenever you see a bird, it's easy to kind of identify that you mean to say a bird. However, 5,000-ish years later, we expect little kids to intuitively, freely, and easily to get these funny shapes that you see here on the screen, which are basically lines and squares, and match a verbal sound to these shapes. Is it intuitive? No. Is it easy? Definitely not. Can you live without it? No. And I will talk a little bit about it as well. And basically, in order to do that, our brain had to engage neural circuits, brain regions that were related to visual processing, just to see things, auditory processing, to listen and to understand language, and, which will be the topic of my talk, attention. You need to pay attention. You need to look at what you're supposed to be looking at and merge it all together. So it's really not easy to many, many populations. And why is it important? Because basically children who fail to achieve reading ability in the proficient way have both social problems, emotional problems, and of course academic issues. And Americans, I still work in the States, so I keep hearing the statistics about what happens 10 years from now, what will happen 10 years from now. So basically the statistics report of 90% of the children who fail to reach the reading achievement, the reading ability, the average reading ability at the age of 9, which is 3rd grade, will find themselves in prison 10 years later. So I know it sounds robust, but this is why this issue is very, very important. And in the US, they put lots of funding into improving children's learning ability early, and maybe even preventing reading difficulties. So who suffers from reading difficulties? Many, many neurological and developmental disorders. So we have, this is just a slide that summarizes some of our work in the recent years. We have children with psychiatric disorders, like mood disorders, anxiety disorders, behavioral disorders like ODD. We have children with attention deficit problems. We have children with epilepsy, that suffer from reading difficulties, and of course dyslexia. And if you think about it, it kind of makes sense, because if the brain has to engage so many regions, like an orchestra, in order to read and to do this intuitive ability, then of course that different problems in different spots in this matrix can eventually result in reading problems. So we're not just talking about children with dyslexia as we would think of someone has reading problems, he has dyslexia. No, there's many, many other populations. Today I'm going to talk just about dyslexia, but keep in mind that in the lab here and in my lab in the United States, we work on many, many disorders, including autism, ADHD, kids with epilepsy, auditory disorders, and so on and so forth. So dyslexia. Dyslexia is defined as a continuous issue with reading, with reading achievements, although they have, these individuals have repeated exposure to the written language, so it's not that they were just not exposed, they were exposed, they went through remedial intervention, and still they could not read. So something is not working right, although this exposure, we're talking about 15% of the population, and there's many, many theories that say, okay, why, what's the reason for dyslexia? What's the mechanism that causes dyslexia? There are many, many more, many mechanisms here proposed here, but I would like to draw your attention to the accumulate literature points at executive functions, a problem with some basic mechanism that is one of the causes for dyslexia. What are executive functions? You can look at the pyramid here to your left. You see that executive functions, it's kind of an umbrella term. Lots of cognitive psychologists still cannot decide what it includes. It includes so many things, all our basic abilities that enable us to learn, basically, which is memory, attention, our ability to inhibit our responses, don't respond really quickly, just hold off for a second, speed of processing, and so on and so forth. And you see that in order to be able to comprehend what you read, which is basically what we expect our kids in the classroom, right? After a child reads a paragraph, we ask them, what did you read? So we expect them to comprehend. Reading comprehension relies on technical reading, on also on language abilities, but also on executive functions, and this is what we do in the lab. We try to break it into the subcomponents of it and to see which one contributes the most to reading. And we can look at the results here to your right. You can see that already in 5-year-old kids, increased activation in these frontal regions are related to future better reading ability. So the brain needs to engage these regions in order to read better. And we see more evidence coming up in recent years showing that increased gray matter volume in the prefrontal cortex, which is another region in the frontal region of the brain that is part of the executive functions and of several executive functions networks, and it was related. Increased gray matter volume was related to increased reading comprehension, both in children with dyslexia and typical readers. So there's increased interest in the in the research in the scientific community on this topic. We also found in our lab, published really like 2 days ago, and I think my PhD student is here, Emma, published on the Salience Network, which is a network that is in charge of monitoring overall processes, overall cognitive processes. We found decreased connectivity within this network that was related to decreased memory ability in these kids and decreased reading. And we found more evidence about error monitoring that is lower in these readers, not only in reading, but also in general cognitive abilities. And so, since we're great believers in intervention, and we don't just want to characterize, say, okay, this is the problem. What are we going to do with the problem? Basically, that's what parents are asking us. So we decided that if the problem of children with reading problems is emergence of both executive functions and problem reading written material, why won't we try to train them on an executive functions-based reading program and see whether we can get an improvement both in reading and in executive function and how it looks like in the brain. So we used a program called the Reading Acceleration Program. Sorry, this is a program that was developed by my late supervisor, Professor Tzvi from University of Haifa. And why is it an executive functions-based reading problem? So this program is presenting sentences on the screen, and after the child finishes reading one sentence, child needs to push a button. The program actually measures how long it takes for the child to read each letter. And then after several sentences like that and comprehension questions that follow it, because we don't want to see just technical reading, we want to see that they're actually reading, we start deleting the letters from the screen in a speeded manner. So the letters are being deleted faster and faster, and we're still monitoring comprehension, reading comprehension afterwards. So why is it an executive function program? Because an executive functions-based program, because we're actually training the child to visually track the letters. So there's visual attention component into it, both speed of processing, because they have to do it faster and faster, and they also have to capture the words holistically. I'm sorry for doing that. Capture the words holistically, and therefore there is some memory component into it. And actually this is what we found. So how are we going to do it? We have to scan children in order to understand some pathways. As I said, scanning children is scanning healthy children is very, very challenging. For research purposes, we do not provide any anesthesia. We're not injecting anything to the child. We're going through a very long desensitization process to make them lay down and actually feel that it's part of a big game. So it takes a lot of time, and sometimes for a 30-minute scan, we need to work with the child for an hour and a half. So it takes a lot of time, but it's very, very rewarding. And so what you see here is a picture of me with Casey, a child from Cincinnati Children's Hospital. And I'm happy to say that we started 3 months ago to scan healthy children also here in Israel. We got an approval for the Ministry of Health to scan children as young as 8 years old, and we're actually doing it here in Tel Aviv University, which make me again feel very happy because it's, as I said, coming back home. And this participant, her mother, who's me, signed the consent to show the picture. This is Hila. She has lots of scanning hours here and in the States, and she just enjoys it a lot, and I enjoy to see her pretty brain. So we do it in Israel, and hopefully in a year or so I can show you some results from our fresh scans. So, as I said, we saw that following intervention, we can show some ability to learn from errors in children with reading problems, but we don't know what the pathway is, and we don't know what neural circuits are involved in this improved reading. So in order to do that, I'm going to skip a little bit because I think I'm a little bit behind. We enrolled 8 to 12 years old kids, 18 kids with reading problems, and 18 kids with who are typical readers, and we made sure that they don't have any attention problems. We scanned them, we scanned the kids, we administered some behavioral testing for reading and for executive functions. They trained for 4 weeks, 5 times per week, for 20 minutes per day, at home, online, and we monitored the whole process. Then we scanned them again, we called them again, we scanned them, and they did some behavioral testing. What did we find? We found that after this reading intervention program, silent reading, which is this graph here, was much faster, significantly faster, both in individuals with dyslexia and in typical readers, post this 4 weeks intervention. And we found that reading comprehension got also improved, although only in children with dyslexia, which kind of makes sense because typical readers already started in the ceiling. We found improvement in executive functions measures, and here I'm going to show you just specific 2 parameters. Visual attention, which went up in children with dyslexia and typical readers as well. And they read and they name object much faster after intervention, as opposed to no effect in individuals who are typical readers. Now, as to neuroimaging, what we did here, we looked at word reading tasks. The kids had to read in the scanner silently, and we looked at their brain activation before and after intervention. And we found that before intervention, and this is an average of brains of children with dyslexia, before intervention here on the left side and after intervention on the right side, when they read words. And so before intervention, we see a very distributed brain activation, both in frontal regions related to effort, related to executive functioning effort, and in posterior regions and some phonological related regions. So they were attempting really hard to read the words that we gave them. And we see some mirror image in the right side also. And I didn't tell you, but during reading, the left side is taking much of the overload work when you read, and also when you comprehend language for most right lateralized people. And so we did not find this dual lateralization in typical readers, only in children with dyslexia. And so after 4 weeks of intervention, we saw a shift of activation to the left side of the brain. So as you see, the activation here is more focal, it's more visual, and some additional attempt to actually decode the letters to understand what the letters mean. We also see a little bit of a signature in the right hemisphere in the right side of the brain. Maybe this is the signature for dyslexia. So I will move forward a little bit because I'm running out of time. I wanted to show you lots and lots of results that we have showing that, for example, here in individuals with dyslexia after this intervention, we see stronger functional connections. So regions are working together in synchrony, as you see here. After this training, you see here this little dot, red dot is the region that is in charge of monitoring errors, saying, hey, you made an error, oops. And this dot here resembles the region that is in charge of word reading. And so after intervention, these regions are working together in synchrony in these children with dyslexia. Of course, it came with improved reading ability. And what you see here in these lines, for those of you who are electrophysiologists, you kind of recognize it. That came from EEG ERP analysis. So we found the same results both in EEG and in functional MRI. We found increased functional connections within a network that is specific for error monitoring. So we can do these things in functional MRI with a great spatial resolution. So this is before intervention, which is less red, and after intervention, it means that the network is highly connected, and it came with improved reading. I'll move just a little bit and I'll say that we tried to use the same intervention in children with ADHD who suffer from reading difficulties. And we say, okay, hey, is that the same population or is it a different population? Obviously, it's different. A different population has different gains. So after this kind of training, Same training, we found increased connectivity, increased synchrony in children with ADHD responding to the same intervention differently. These individuals showed increased functional connections between attention network and dorsal attention network that is both are part of the executive function system, but we didn't find an involvement of the visual system that basically is more working in a more atypical way in individuals with dyslexia. So to conclude, fMRI in healthy individuals is feasible and provides valuable data. We can train individuals with dyslexia to read better. We saw an involvement of cognitive control networks in the process, which kind of made us think and feel that maybe other populations with low executive functions like autism, like children with epilepsy, children who were born preterm, and we know that here in Israel with the IVF we have many children born preterm, whereas the frontal region is not mature yet. So we would love to look at this population as well, and we're looking at it already. And I will pass through this, and I will say that we think that executive functions, basically, we hypothesize that maybe in executive functions are like the conductor in an orchestra, whereas all the tools, language, visual processing, they have to be there, and executive functions put them together in order to eventually be able to read. As I said, this is just the tip of the iceberg, and our studies are basically looking from the genetic components to neurotransmitters, taking me back to my master's degree, spectroscopy data that we collect using the scanner, to brain imaging, which is fMRI, MRI, DTI, diffusion data. We have many collaborators here in Tel Aviv University. We look at environmental factors. What about parents for children with dyslexia or reading problems? Do they read to their kids? Why? Why not? I mean, reading to your child is very important. Some parents don't know that they can just speak to their kids, and it's as good as reading to your child. So we're looking at that as some kind of an environmental mapping and education. And of course, at the end of the day, we're looking at behavior. There's many collaborators on these projects, and some of my Technion colleagues from computer sciences, electrical engineering, and Dedi, of course. I'm trying to bring them to the table and to kind of work with me on this exciting data. As I said, it's a lot of people's work, and thank you so much for your attention. Thanks. So it's an excellent question. Wernicke area was not there. There were some temporal regions related to comprehension of language, but it wasn't Wernicke. And the frontal region was indeed Broca area. And the thing is, what we assume is that, think about a child with dyslexia as a child that tries to lift a huge bucket of water. Okay, so eventually the child can do that, but it demands so much effort. And he's sweating, and so this is how the brain of a child with dyslexia looks like when they're trying to read. Broca is the production. None of us is producing, trying to verbalize every word that we read. Otherwise, as a good reader, you won't be able to read a whole paragraph. But when you're trying really hard, you're verbalizing, kind of, what does it mean? What is it? What is it? In your internal speech. So we think that this is why we don't see these regions after intervention, because the process became more automatic, and when it's more automatic, you don't need to do these subvocalization.